Hey guys, I'm a science potato, and today I have a video on advanced Gcode, start and end Gcode commands in Cura. So first thing we'll do is open up our printer to get to our start and end Gcode. And we've got our machine settings open here. So we can see we have our start Gcode and our end Gcode. So this is what's put in front of the Gcode that Cura generates for every print that you do. So this is where the homing commands are, the temperature presets, stuff like that. And there's a bunch of values here. You'll notice G code and M code. There's all a G and an M in front of everything here. And then there's a little comma here, and after that is just comments. I make sure to comment every single line of G code that I put in here so that it's very clear what the function of that G code is. Because a lot of the stuff like G90, how are you supposed to know what G90 means? Well, an easy way to look it up is on the RepRap wiki. So just like Wikipedia, there's a wiki called the RepRap wiki, which is for 3D printers. And on it is a G-code page. So all you have to do is Google RepRap wiki G-code, and it'll take you to this page here. So we've got our G-code open. We can see the index here. It is huge. There's hundreds and hundreds of commands here. We can go all the way through it. So if you're not sure where to find what you're looking for, you can just use the search command or the find. So you press Control F, and then you'll get a pop-up asking what you want to look for. If you're looking for probe settings, you can type in probe, and you can scroll through different probe functions that it finds. So back to our code here, we can see our very first line is a G90, which is for absolute positioning. So you have to choose between absolute and sorry, I forget what the other one's called. Absolute positioning and relative positioning. There we go. And you're pretty much always going to use absolute. That's why I forgot about relative, because you're basically never going to use that. And then the next few lines I have has special commands in the start G-code that only Cura has. Most other slicers can't actually have this. You see I have an MO4, which is for setting the hot end temperature, but there's no actual value in there. What I've put in there instead is a command that actually takes that value from the slicer settings itself. So it's going to find material print temperature, whatever value I've put in that setting, and it's going to place it in here when this code is generated. And I've done that to bypass and speed up the way 3D printers normally work. So normally when you start a print, the first thing it does is it preheats. It'll start by preheating the build plate, and then it'll preheat the hot end, and then it'll home the machine, it'll go through the rest of its startup commands. But I run a large print farm, and I need to make things as efficient as possible, so I've written my own start and end G-codes here to make things better and easier. So for the first thing here, we have our hot end temp, but it is an MO4, and if we look down here, there's another hot end temp, but it's MO9. So an MO9 command is what most generic 3D printers use. An MO9 forces the machine to heat up, and it forces it to wait and not to continue reading the G-code commands until it is done heating up. So that takes a long time. So what I do instead is I start with an M104, which tells the printer to heat up, but it doesn't actually wait for it to heat up. It just starts heating up, and then it continues on to the next functions while it's heating up. So first it's going to heat up the hot end, then while that's heating up, it's going to heat up the build plate, then while that's heating up, it's going to run through the rest of these commands as well. M140 is for heating the build plate. We also have an M900 here, so this is our linear advance. So normally when you're calculating linear advance, you're going to calculate it for a specific layer height or a specific line width, and then if you change it, you need to adjust those variables. But because of the way Cura works with its advanced G-code functions, we don't have to do any of that. We can see here I've used the same command where I'm using these special brackets to pull data directly from Cura. So it pulls my line width variable, my layer height, and my material diameter, does a bunch of math, and then gives this data to the firmware in the printer, which I have other settings tuned for linear advance, so that it does all that math for me anytime I change any of the variables. So now I never have to retest for different layer heights or different nozzles or anything like that. It's always computed for the settings that were set in the slicer for that specific job. So this saves huge amounts of effort trying to do this manually. And now it's all automated because of the way Cura works. And the next thing we're going to do is we're going to move to 5 millimeters on the z-axis. But this is very specific in the way this will function, because if you notice right underneath it is a home all axis command, a homing command. So we're telling it to move before we've actually done a homing command. So that means it can work in two different ways. If this printer, say, was just turned on and has not been homed and doesn't know where it is, it's not going to move to a position of 5 millimeters above the build plate because it has no 0. It will see its current position as 0, which means when you start the print, it's going to move the z-axis up 5 millimeters, and then it'll do this homing command. But if your machine, say you just finished a print and the machine knows where it is, and you start a print, now instead of raising the gantry 5 millimeters, it will lower it down till it is 5 millimeters above the build plate. So it'll have a different function depending on whether the machine has been homed or not before it reads that command, which is fine because it works either way. But we do this just to make sure that if there's clips or something on the build plate, the hot end is lifted up a bit so that's not going to hit any of those clips when it goes to home itself. We do our homing command here, and then we move our z-axis up 0.3 millimeters or 1 layer height. We always use a 0.3 millimeter layer height as our initial layer height. So we've put it into the Gcode to just automatically go to that height. Now we reach our M109 command, where now that it's done everything else, it will finally sit there and just wait for the hot end to finish heating up. Notice it does not wait for the build plate. The build plate is told to heat up with this M140, but it is not waiting for it to finish heating up. So as long as that hot end is at temp, it will continue on with that print. So then it's going to zero itself, and then here I've just written in basically a purge line. It just draws a little line right at the starting position of a purge line before doing another zero of the extruder, a small retraction of 0.5 millimeter here, and then M117 basically puts whatever text you have after it. You can see here it says doing the science. It displays that text on the control box after you start the print. So whatever text you put there, it'll just say that on the printer. And now that it's read through the start Gcode, it will do a travel move to its starting position, and it will start printing the part. So it's been however long, your part's done. Now it's going to run through the ng code. So the ng code is a bit simpler, but still has some nice features in it. So we've got an M104 and an M140 setting our temps to 0, so effectively turning off our build plate and our hot end. Then we set our positions to relative values rather than absolute. And here we lift our z-axis up 3 millimeters. So as soon as it finishes the print, the first thing it's going to do is lift up off the print so it's not oozing onto it. And then it's going to home just the x-axis. That will get the hot end out of the way, for it to then bring the y-axis forward to y290. Our build plate is 300 millimeters on the y-axis. So by bringing it to 290, it's going to present the build plate to you. It's going to bring it forward so it's easy for you to pick your part off of it. And then this last one is the most important here. You can see we tell it to disable the X and the Y stepper motors. Now most G-codes will have an M84, but only an M84. You can see I have M84XY, which means it's only going to disable the X and the Y stepper motors, which means your Z-axis stepper motors will stay locked and engaged and in the proper position. We use CR10 printers with 2 Z-axis lead screws, so when those stepper motors turn off, there's a chance that that gantry can become misaligned. But by only turning off our X and our Y stepper motors, those Z-axis motors will stay engaged as long as that printer is on, and you will not lose alignment on your gantry. That's really important for us. Like I said, we have a huge print farm, and I can't be going around to these printers trying to level gantries all day. So we never turn our printers off, which means their Z-axis motors are always locked and always in the proper position. And again, if there's any other info you're looking for regarding Gcode commands, you can look at the RepRap wiki. You can just Google search RepRap wiki Gcode, and it'll take you right to the Gcode page. And that's where I found the vast majority of these commands. And I've built my own start and end Gcode profiles that I use for my machines. And in doing so, you learn much more about the machine and what it's capable of, and increase your skills in general. Alright, that's all I've got for this video. If you like it, please like and subscribe. It helps a lot. I'll be making more 3D printing and 3D design videos in the future. Alright, thanks. Bye.